Howdy and good day, fellers. Today in Algebra, we are going over CO16, the answers, the OR statements, the word problems, and then we're going to get into CO17, although we will finish it up tomorrow. It is big brain math stuff, and then your test, plan on next Tuesday and Wednesday, as I've said earlier, Tuesday and Wednesday. So flip over to the second page, and let's take a look at the three OR statements that we have here. The fact that they're OR statements, first of all, like we talked about, it's easy to see you're dealing with an OR statement because it's got the word OR in it, but you are solving each of those inequalities separately. Okay, it's almost like you've got two completely different inequalities that you just end up graphing on the same number line. Okay, so don't think of them as together. So you got 3h is less than -6 after subtracting 1 from both sides. Divide both sides by 3, and h is less than -2. That's 1. The other one, adding 5 to both sides. You've got 2h is greater than 12. Divide both sides by 2, and h is greater than 6. Okay? And what we're saying here is that our graph is going to give us a range of numbers that will either be less than -2 or greater than 6. And if we pick a value within those ranges, it's going to work in one inequality or the other. Okay? If we pick a value less than -2, it's going to work in that one. If we pick a value greater than 6, it's going to work in that one. If we pick something not in either range, something that's in the middle, it's not going to work in either of them. Okay? But if you thought about checking this by seeing what works in both inequalities, you're not going to find it. Are we settled back there? Yeah. Okay. Yes. Okay. And we're good here? Okay. What? Oh, that little box? I figure it'll go away. It'll go away eventually. Yeah, I hope so too. Okay, next one. Same situation. We're going to solve each one separately. So we've got subtract 1 from both sides, and that gives us 4c is less than or equal to -4. Divide by 4, c is less than or equal to -1. And then on the right side, add 3 to both sides. We get 5c is greater than 20. Divided by 5, c is greater than 4. Okay? So those are the two inequality solutions you should have. Graphing them, we have an open circle at 4 going to the right, a closed circle at -1 going to the left. Questions on that? Yes? Plus 3? For the one here? Just to move that constant over. I didn't write what I did here. Here I subtracted 1 from both sides. It's my first step, and I didn't write it, but that time I did. Sorry. I should be more consistent, shouldn't I? Yeah. The last one, we've got 3/5 times 10x plus 20. Maybe you noticed, maybe you didn't, but it's kind of nice that our denominator of that fraction is a factor of the numbers that we're multiplying it by, right? 5 is a factor of 10, and 5 is a factor of 20. That matters because you probably noticed once you actually multiplied, what types of numbers did we get here? 3/5 times 10 and 3/5 times 20. Whole numbers, okay? 3/5 of 10 is 6. 3/5 of 20 is 12. And that's less than 24. Okay? You will be able to use a calculator on this test, but anything that we can do mentally, then we should. Yeah. I think every test going forward, you'll have calculator privileges. Subtract 12 from both sides. We get 6x is less than 12. Divide both sides by 6. And x is less than 2. On the right side, the inequality is so short because I just ran out of room on the page. But you're going to divide both sides by 6. And we get x is greater than 10. Okay? It's an OR statement. So open circles above 2 and above 10. And that's what it looks like. Questions on those three? Okay. The word problem about this unique pollinating plant, which I don't think actually exists, but it worked for my needing an or statement, so I used it. But your inequality statement is essentially here. Less than 3 feet tall or greater than 5 feet tall. Okay, a plant can't be both less than 3 feet and greater than 5 feet, and that's why it's an or statement. It's got to be one or the other, or neither. Okay, so your inequality, I suppose we can use h for height. The height is less than 3, or the height is greater than 5. That describes the heights for which the plant pollinates. The graph of this, open circles at 3 and 5, one going left, one going right. Okay? So this tells us that if it's in between 3 and 5, then it doesn't pollinate. Now, yes, should there technically probably be a 0 over here as the other limit? You can't have a negative height plant. Does this plant grow forever and ever and ever? And no, but it gets the point across of that contextual or statement. The last one, in a dance competition, routines must be 8 minutes, 30 seconds with a standard deviation, which this is the same thing as absolute deviation. Okay, we covered that in CO11 of 10 seconds. So just because we are going back to absolute deviation today in CO17, absolute value, what's the whole thing about absolute value, absolute deviation? What does that mean? What is absolute deviation? Daniel? So that's absolute value, right? It's the distance away from 0. Absolute deviation kind of holds that same characteristic, except it's talking about a number other than 0. In this case, our target time is 8 minutes and 30 seconds. Now, the absolute deviation of 10 seconds means that you can go 10 seconds longer, up to 8 minutes and 40 seconds, or 10 seconds shorter and still be okay, still not lose any points. Okay? So it's pretty tough to get a dance routine to be exactly 8 minutes and 30 seconds. Yeah?
So all of these like brain buster stuff, would that be on the test?
The concept, possibly, but not quite this in depth. Yeah. Okay. And then it says routines that are 15 seconds longer or shorter than this range. This range refers to the 820 to 840, for which there are no point deductions, right? 15 seconds longer than that brings us to 855. What type of circle do we have above 840 here? If a routine longer than that will lose you points. What type of circle does longer give us? Open or close? Is 840 included?
Open.
Is it the deduction zone or is 840 in the safe zone? It's in the safe zone. Okay. So open circle here, and then up to 15 seconds beyond that, that is going to be your range for losing 2 points on the long end. Right? On the short end, if we fall 10 seconds short, 820, we're still okay. But then 15 seconds beyond that, 15 seconds even shorter than 820, we're going to lose 2 points again. Again, it's an open circle 820 because 820 is in the safe zone there. It's part of that absolute deviation. But then we go to 805, and if our program isn't within that time frame, we're going to lose 2 points as well. Okay. Now, is this saying that a routine can't be 9 minutes? No, but you'll probably lose more points, right? If your routine's only 6 minutes, you're probably going to lose more points than just 2 points. But this is the algebraic way to represent that range for which you will be deducted 2 points based on your time. So it's kind of like we have two and statements within an or statement. You know, it's an or statement because it can't be both too short and too long. That doesn't make any sense. It's got to be one or the other. And it's an and statement because there's a specific range for losing 2 points. It's got to be longer than 840 and less than 855, or shorter than 820 and longer than 805. Okay, so this is the graph that you should have that brain buster question. Okay? If it didn't make a lot of sense reading it, that's the whole challenge behind word problems, right? You have to interpret what it's saying, what it means, the order of things. But now that you see it, does it maybe make a little more sense? I hope. Okay. Bridget asks, will this question be on the concept will, in the sense that I'll give you like the first 6 question and answers to a number game situation, and you'll need to give me the graph of remaining numbers that it could be. Okay, so similar, but right, and you've played it, I mean, like 10 times, so you're very familiar with it. Yeah. Okay. Any other questions on CO16? Okay. Our final objective of the unit, which usually means we're going to kind of summarize everything that we've done so far. Not harder, just a summary. Okay. So CO17 is we are going to be solving absolute value inequalities, right? If you think back to our progression through the unit, CO11 was absolute value, CO14 started inequalities, and now we're kind of putting those two things together to be absolute value inequalities. So before we dive deep into this, I want to just refresh ourselves. What does that mean? Going back to CO11, back to an absolute value equation, what does that mean? Lucas? That's what it says, but what does it mean? What does it mean? Thumper? No. It doesn't mean, I mean, yes, x does equal 5, but it's not what it means. Brady? It's like saying 5 equals how far away x is from 0. Sure, yeah, that whole concept of absolute value is how far something away is from 0. So when we read this and we say the distance of x, or x is a distance of 5 from 0, what two values does x equal? 5 is one of them. Good job. High five. But also, Lucas, -5, right? There were two answers to this because there are two sides to 0. Okay? So now, let's translate that to inequalities. All I've changed here is I made the equal sign into a less than symbol. So when I say the absolute value of x is less than 5, what does that mean? If the equation means that the distance of x from 0 is 5, and recall that the equal sign, it means is, the absolute value of x is 5, what would this one mean? Gabby? Okay. What Gabby said was that the distance of x is less than 5 from 0. Okay? She actually said it probably a little more succinctly, where she said x is less than 5 from 0, but just remembering here that we've got that distance there. So x is less than 5 from 0. So what two numbers, if we were to kind of make a number line here, what two numbers could x be between? If x is less than 5 from 0, what two numbers can x be between? Elise? 5 and -5. Does this look pretty familiar? Does it look familiar now? Okay. Absolute value inequalities require an understanding of compound inequalities because we have that other side of 0. Okay. If x has to be less than 5 from 0, x can be anywhere between -5 and +5, not including them, okay? Because those values are all within 5 to 0, a distance less than 5 from 0. So as an inequality, going from the graph to an inequality, we would say that x is between -5 and +5, or -5 is less than x, which is less than 5. Right? It's the summary, it's the culmination, right? I've said it before, math is like that scaffold. We've been building up to this with everything else that we've done previously. Okay? So the next one. The absolute value of x plus 4 is less than 8. means what? Is that a hand up, Elise? Go ahead.
The distance of x plus 4 is less than 8 from 0.
Yeah, and now that we've established that distance piece, it's probably just word clutter. We can take it out, but essentially, yes. What this is saying is that x plus 4 is less than 8 from 0. We do still need that from 0 in there because just saying x plus 4 is less than 8, that's only half of it, right? X plus 4 is less than 8 from 0 means we have to include both sides of it. So if we were to graph this, saying what two numbers could x plus 4 be between, what's our low limit and our high limit here? What two numbers could x plus 4 be between if we know it's less than 8 from 0? Lauren? -8, +8. Right? Anything between those numbers is less than 8 from 0. We have open circles above each of them again, because it is just a less than symbol, and we are connecting. So x plus 4 can be anything within that range. As an inequality, what type of inequality statement will we have? And or? An and statement. -8 is less than x plus 4, which is less than 8. Quinn?
Wouldn't the number inside of the, from where it goes from -8 to 8, wouldn't that be -3 to 3 because -3 plus, oh no, that wouldn't.
Are you thinking -4 to 4?
Yeah.
Because we subtract 4. So notice how we aren't solving this yet, right? You already know how to solve an inequality such as this. We did that in CO16. You subtract 4 from all three parts and you'd be solving for x. Right now, what this is helping you do is knowing how to solve this, right? How you solve an absolute value inequality is you first need to write it as a compound inequality and then solve it. Okay, we had to write this as a compound inequality so we could graph it. You already know how to do this, how to solve this once we get to this point. This is getting from here to there, right? So your actual homework, you will have to solve it. But right now, we're focusing on the new piece, which is interpreting what an absolute value inequality means, okay? Anyone like totally, completely lost and not afraid to admit it because this is new, okay? It's okay, all right? Can you kind of articulate where you're getting stuck? It starts with your understanding of absolute value, right? And recognizing that, that is a distance, okay, which means we're including both sides of 0. And the absolute value is where this from 0 comes from. If the absolute value bars weren't there, that would just say x plus 4 is less than 8, and that'd be it. But those bars, adding that from 0 means that we have to include both sides. So the two numbers that are 8 away from 0 are -8 and +8. X plus 4 has to be less than -8 from 0, which includes all these numbers here. And it has to be less than +8 from 0, which are all those numbers there. Okay? The next one, and I'm going to erase this, so get these notes down if you need them quick here. Anybody else? Okay, all right. The next one says the absolute value of x is greater than 15. What does that mean? The absolute value of x is greater than 15. What does that mean? Thumper. Farther away, I'll say more, just for that greater than piece. But yeah, x is more than 15 from 0. Because we have the greater than symbol. It's going to be more than 15 from 0. So what does x have to be less than, and what would x have to be greater than? Notice I'm asking you two questions now. Not what is x between, but what does x have to be less than, and what does x have to be greater than to be more than 15 from 0? Erica?
It has to be less than -15.
Very good. It has to be less than -15 and greater than +15. Are you seeing where I'm going with this?
Yes.
Here's an or statement, right? For x to be more than 15 from 0, it's got to be one or the other. Beyond -15 on the negative side, or beyond +15 on the positive side. As an inequality, x is less than -15, or x is greater than +15. The last one, the absolute value of x minus 10 is greater than 7. What does that mean? Brady?
It has to be either less than -7 or more than 7.
Basically, it's got to be further or more than 7 from 0, right? X minus 10 is more than 7 from 0, which is why we have to include that negative side and the positive side. The two numbers x has to be further than are -7 and +7. Okay? Further than -7 means that x is less than -7. Further than +7 means that I say x minus 10 is greater than +7. So our two inequalities that we can write here, x minus 10 is less than -7, or x minus 10 is greater than +7. Now we haven't solved it yet, but you know how to solve that now, right? Draw the line down the middle, solve each inequality separately, graph on the same number line. You know, our job here is to get from, what does this mean? How do I solve that? Transfer it to an or statement. Okay? How do I solve this? Transfer it to an or statement. Daniel? I don't know what your homework is going to be yet. We'll see how far we get. Haven't really decided. With a 2-day plan to teach this, we'll see where we end up. Okay? But the initial challenge is the setting up. Like once you get here, you know, the solving piece of it, I hope that's a little bit easier. It's the new part getting there. So I've copyrighted and patented a little trick to help you. Okay, a less than symbol will always be an and statement, like the first two examples we had, right? It was a less than symbol to be an and statement. For the second two we had, a greater symbol is going to be an or statement. Isn't that helpful? Copyright, patented, Schultz, 2016, or something like that. Okay? Yes. Yes, my nifty tidbits can go on a help sheet. Yeah. Basically, stay away from anything within the pencil sections because that's your actual homework. You can't ever have actual worked out examples. There are a few exceptions to that where, depending on what the concept is, and we'll talk about that as they come up. But as a 98.2% of the time general rule, stay away from the
Just don't write anything down.
pencil sections. Yeah.
Just don't do
Okay.
a help sheet.
Or don't do a help sheet. That would avoid any confusion. Don't recommend that though, but yeah. So the goal of this, right? Oh yeah, go ahead.
Can you write down like the equation that we just did? Those, can you write those down?
What's the top of the page? Is it a key point? So this would be the one of those 1.8% of the time exceptions, I suppose, where, hold on, I'm just flipping to the page. Yeah, so you can write any of the notes that we've had here. You couldn't show how to solve this, but you can show that this inequality means that. Okay? Because we didn't actually solve it in our notes, you wouldn't be able to show how to solve it on your help sheet. But since we did do this in the notes, then that would be fine on a help sheet. Okay? But essentially, the goal here, remember when with absolute value equations, how our goal was to isolate the bars? Okay? If there's other stuff with the absolute value bars, and we see that in our fourth one, starting out with our second one here, right? We got a -6. We have to take care of that first. We have a 2 out in front. Have to take care of that first. So once you isolate the bars, then you need to rewrite as a compound inequality. And how you know which type of compound inequality to use and or depends on the sign you have. Less than, and. Greater, or. Okay? How are we doing so far? Decent. All right. So let's look at some examples here, and let's practice what I've preached. Okay? It says solve each absolute value inequality and graph the solution. So these parts you could not put on a help sheet because it's under the pencil section here. But starting with the absolute value of x plus 7 is less than or equal to 12. Are the absolute value bars by themselves? Yes. So we're going to go straight to our compound inequality. Bless you. What type of inequality are we going to have here? And or? And we know that because of the less than symbol. Okay? So what this means is that x plus 7 has to be, what? Oh, has to be within 12 of 0, or less than 12 from 0. So the two numbers that x plus 7 can be between are -12 and +12. In the above examples, we kind of graphed it first, if that helps you. If you want to say, okay, so this means that -12 and +12, it's got to be less than 12 from 0. So this is my graph of that situation, and then go to the inequality. That's fine. Just remember that graph isn't your solution, right? That's just the graph of what the original inequality is. We still need to solve for x, and we do that once we write it as a compound inequality here. So once you get that far, now it's just back to CO16. How do we solve this? Yes. Bridget.
You do the 7 or -7.
Subtract 7 from all three parts, because it is an and statement, so we're solving the whole thing together. And we get -19 is less than or equal to x is less than or equal to 5. And that is your solution statement. You've told me what numbers x needs to be between to make the original inequality within 12 of 0. So your answer here, your solution graph, would be a -19, a +5, closed circles this time because it is or equal to, and connected. Not going away from each other. That would be an or statement, right? And we know it's an and statement because it is that less than symbol. That would be your solution graph. Okay?
Are all and statements, are they all connected?
Yep. And or statements are all going opposite directions away from each other. Okay? All right. Let's try, before we go, and there won't be any homework tonight.
There's one for just hands.
Sounds like some people are excited back there.
He's gonna do your homework.
Can we look at the third one?
Yeah.
The third one. The absolute value of x plus 10 is greater than 15. We kind of had a similar example to this up above. It was x minus 10, I think, and I don't know. But, greater than 7. But what does this mean? Okay, what type of statement do we have? And how we write it? It's an or statement, and we know that because it's the greater symbol. And what this means is that x plus 10 is less than negative 15, because it's got to be further than negative 15, right? More than 15 away from 0. Or x plus 10 is greater than positive 15. Okay? If you want to graph this first, just the original inequalities to help you visualize, right? X plus 10 has to be more than 15 from 0. That means it's got to be negative 15 or further going left, positive 15 or further going right. Right? And that's what this inequality here says. That, I have x plus 0. Hold on. Sorry. X plus 10 is greater than 15. Okay? And now we can solve it. Right? Our work up above in the note section got us to this point. Our knowledge of CO16 allows us to solve it. So we are going to treat these separately since it is an or statement. We're going to subtract 10 from both sides. We get x is less than negative 25. Subtract 10 from both sides on the other side, and we get x is greater than 5. I've lost my ability to do math here, I think. X is greater than 5. Okay? It's not good. Graphing our solution, it's an or statement. X is less than negative 25. X is greater than 5. That's what it's going to look like. Okay? So there's your intro to it. We will finish this up tomorrow. We'll do the other 2 examples where the bars aren't by themselves to start. We'll do some on the back side perhaps as well, or the second page. And then you'll get your practice test tomorrow. So you have the weekend to work on it. We'll go over the practice test and have a review sesh on Monday. Shh. Hey, hold on. I'm not done, folks. Hold on. We'll go over the practice test and have a review session on Monday. And then your test will be Tuesday and Wednesday. It's a 2-day test. Wednesday is a little bit shorter period because of mass, but I think a period and a half will be enough time. All right, that, folks, is how you math.